We're going to look at the Pythagorean Theorem. 3,000 years ago, Pythagoras determined the relationship of the legs of a right triangle to the hypotenuse. Some historians say he stole it from the Egyptians. Some even claim he stole it from the Chinese. I'm not here to talk about legalities. I'm talking about the Pythagorean Theorem. The legs of the right triangle are A and B. The hypotenuse, the long side, is identified as C. This symbol, of course, identifies these triangles as right triangles. And as Pythagoras discovered, or borrowed, he found that if we square one of the legs, square the other leg, their sum is equal to the square of the hypotenuse. Now, we have different shaped or different oriented right triangles. It doesn't matter what the orientation is. You can always identify the hypotenuse as the side that is opposite the right angle. So we're going to take a look at how we solve this. Now we're going to bear with me because this is obviously not drawn to scale. But if we make this side, say, 8 and this one 5, we can determine how large C is. How do we do that? Well, again, we use that theorem that he developed, and again proved that A squared plus B squared is equal to C squared. We do our substitution. Square the numbers, we get 64 plus 25 equals C squared. 89 is equal to C squared. We take the square root of each. And the square root of 89 is equal to C. And this symbol, this answer written this way, is an appropriate answer. Now I'm going to take one more and see how we can find out the length of a side if we know one of the sides and the hypotenuse. So let me quickly erase this, and I'm going to change my numbers. As a matter of fact, I'm going to leave one of them. I'm going to leave a 5 here. And my hypotenuse has a length of 13. My question is, how long is side A? Again, we go back to the regular formula for the Pythagorean Theorem. We substitute again. Now we don't know A, so A squared plus 5 squared is going to be equal to, that's 13 squared. Following? Good. So A squared is going to be added to 25, and their sum will be 169. We apply, let me leave that squared. We apply the algebra that we know. We subtract 25 from both sides of the equation. So A squared is equal to 144. Take the square root of each. A is equal to 12. So this is 5 to 12 and 13. Pythagorean Theorem. It's difficult to play with, but you'll do fine with it. If you have questions, talk to your tutors, and now get to work. Get to work.